first lab would be all simulation based, and this would be based on tools like MATLAB, Simulink. There are equivalent tools which are more free and open source like Scilab and Sage. Now we can design experiments in Simulink to implement amplitude modulation, frequency modulation, FSK and PSK systems. Likewise, we can show how actually a quantum constellation looks like and works in actual practice in the presence of noise and interference. So various types of bit error rate and interference studies can be conducted in simulation. And it's also possible to do simple communication circuits, again in simulation, using tools like SPICE. There's a variety of SPICE family tools. Communication 2 will be entirely based on implementing communication systems, and the tool of choice there is the USRP, the Universal Software Radio Platform package. And like the slide here says, you can do AM, FM, DPSK, QPSK. You can study what is the effect of frequency offset, what is the effect of an imperfect channel, delay spread in the channel, and we can also introduce them to actual baseband implementations of advanced modulations like ODM and CDMA. So with 2 theory courses and 2 associated labs, we think that we can groom students to be hands-on in communication and start thinking of some advanced projects as well as research in communication. Now this could be a potential list of communication electives: wireless communication, error control coding, SATCOM, OFC, wireless. There should be wireless standards. So we have 2G, 3G, 4G, a variety of standards and various application-specific standards. So all of them can form one course, which would really help students become industry ready. Wireless sensor networks is a hot topic, and cognitive radio and cooperative communication are very, very current subject topics also. So depending on what the faculty expertise is, any of these could be the electives. Miscellaneous ideas that are worth implementing. So some of these are general ideas. We don't have very specific, manifestations in communication. So probably we would like to introduce MATLAB and Scilab skills early as first or second semester. We would like students to design-based experiments and feel more motivated in the lab. I think we should teach them maths and signals very well because they are foundational to this domain. They should be done by experts who are applied in their work and research. Tutorials, we should ensure that tutorials become the basic material that goes into quizzes. That way they're taken more seriously because this is one subject that's best learned by problem solving. We should incorporate self-learning methods, paper reading, seminars, so that students are exposed to real problems and issues out in the industry. And I think we can use our autonomy a little more efficiently by helping students gain self-esteem in this domain and incorporating multiple ways of learning. So that would be the summary for our group. Thank you very much.
Thank you. Next.
And basically we are having 2 system groups. One is computer networks, another one is operating system. I am discussing about the computer networks. And basically most of the universities, so our group of experts are Professor Keshav Nori, Dr. Kodavok, and Dr. B.S. Manoj, and we are associated with our participants, Professor V.S. Ananta Narayana, Professor Shanti, and myself, Navajesh, Nancy Rani, and Shankar Babu, and Sadhya. And as far as computer networks is considered, most of the universities are looking this as a 1-level course, and some of the teachers are expressing that it has to be taught in 2 levels. So first level we would like to have this data communication, the first part. This will be like a prerequisite, otherwise people will not able to write programming part clearly. So in our data communication, they have to cover the lower layers first, like physical layer, data link layer, and focusing more on MAC networking, lower level layer networks, how Ethernet is working. And once that part is covered as a prerequisite, then we can able to justify the course as a networking part. As you know, to understand this subject, in between we are having good number SSL, and programming part one has to have either in C or C++ or Java. And in operating system we are having inter-process communication. So so that people can able to write what is a pipe. Once they understand what is a pipe, then in network programming they can able to understand the system calls pertaining to socket. So that's why all these things we have made it as a prerequisite to understand our computer network course. And here, during the data communication time, most of the students do not know about what is a switch, what is a hub, and what is a router. And most of the universities are simply covering computer networks as a kind of theoretical part of it. And they do not know the router, and they start speaking more on routing algorithms. So adaptive routing, non-adaptive routing, and in the end of the day, we say, have you seen the router, switch, and how they think that it is the electronic student's job. So that's why we would like to have certain simulators pertaining to this router configuration and processor. Katoga has given us the idea about VIETA. So VIETA is a virtual router which we can work on laptop. So I have been teaching computer networks for the last 10 years, but I do not know about this simulation router, virtual router, which is working on the laptop. So thanks to Joseph, and he has given the demo for us how it can be worked out, so that people will have this idea about switch and router configuration. And over and above, we have previous actually. Another one is a open V switch, and from that we can able to have virtual level 2 switch on laptop itself. So it will help us to understand the L2 switch and L3 switch operations in clear. So once the underlying part is much more clear, then above as a networking part, the applications can be written much more clearly. So theoretical part we have not discussed much, because in the end of the day, 7-layer architecture, everybody does teach about the 7-layer architecture. So that's why we have gone for more focus on lab exercises. So in the lab, one has to start with the simple client server programming and how the text can be transmitted, and one has to be very good at the ping program, and in that focusing on how do you calculate round trip time, then how the trace route can be done, and we can have some simulation within the classroom having the laptops, how the route is basically taking place, and they have to understand the trace route part clearly, and DNS performance. Under operating system, people do know about thread concept. So by using that threads, how to write client server program using threads concept, multi-threaded file servers. So not only just focusing on IP version 4, and you know the entire world is looking towards IP version 6. So all these programs one has to write definitely using IP version 6. So that way, the more discussion has taken place in laboratory point of view. And so all these layered architectures are working together. So focusing on interoperability, we need to do some sort of exercises pertaining to RFCs. So that has been discussed. And the outcomes of this is that, of course, we have to start the basics of computer networks, and we have to create a room so that students will get preparedness to do some research work in the network. And our plan is to make the students as a network architect and planner. And this has to become in such a way that in every university after networks, the second level course is there, like mobile hardware networks, mobile computing. So it has to become now like a prerequisite to understand much more clearly. So these are the books we are following most of the universities. And the first book is a pros and cons computer networking, and then the topic is on a top-down approach. So in our team, what we have expressed is the top-down approach is acceptable, but only the couple of first classes they have to teach what is meant by top-down approach. But the actual the mode of instructions should start from bottom-up approach. So only first 2 classes they have to know how the applications are looking like. Then we have to come down from physical layer, data layer, so that they will be able to understand what is a socket. Once you say socket, they have to know IP address which is their network layer, and port number means which is their transport layer. So we have built let the Telegram book be there as a standard book. And the socket programming point of view, definitely one has to refer research business rules. Thank you.
The objectives are listed here. First one is to understand the execution of a program using pair machine. How the program, when the user uses the program, how it gets executed until it is separated from the concept of this operating system. And more emphasis should be given on the concept of concept and lab components, so that both has to go hand in hand so that people can appreciate the course. So previously or its equivalent, because they have to do some programming over there. And syllabus, as far as theory is concerned, the first one is, first component could be the execution of a program in a single programming mode. The student should appreciate envisaging of virtualization, how the virtualization is evolved. So without having any barriers like memory, process, I/O and all, that is assuming that they are infinite. So how we can execute a program is exactly the virtualization concept. Then multi-programming mode with the resource management. So that's a classical OS component where process, memory, disk and information management. Then system calls for process, memory and I/O management, that is introducing the system calls. And another important thing is snapshot of process under execution using system calls. That is how the student should know that how the various layers of operating system will be coming to picture as far as the execution of a program is concerned. Then one more thing which we would like to say is introducing the distributed computing. That is how the different operating system is going to communicate among each other in the distributed environment, mainly introducing the concept of coordination, things like that. And lastly, virtualization concept. This is a new one which is to be included in the operating system. That is typically talking about test of virtualization and server virtualization. What are these two and how they will be useful for the future. Coming to the lab component. So one important thing is before starting the course itself, the student should know how to install and adjust any operating system, more specifically Linux kind of thing, because they should know that how to load an operating system. And another is mundane kind of thing, that is simulation of scheduling algorithms. Again, the student should know something about how to generate a job mix using different distribution functions, and study of system calls, typically create, communicate on intra-process kind of thing, like like pipe, named pipes kind of thing, and signals, that is how the various signals can be sent, and based on that how you can control the process. Memory management, typically demand page memory management. I/O management, in that how a binary file and ASCII files are created, what is the usefulness of that. Next is implementation of some synchronization algorithm to study mutual exclusion problems, so there is another issue. And looking and understanding and available operating system source code such as Minix. Minix is one of the open source operating system which is available, and look into that operating system code and try to modify some of the things and see how the things are working. They are going to be the lab component. And outcomes are going to be, the first one is obvious, so understanding how the basic OS works. Designing modules for operating system. So typically it is not possible to design an entire operating system. Rather than that, take a module and do something, like an existing module, do some tinkering around that and see how the behavior changes. And appreciate the concept of virtualization. So there is a state of art kind of thing. So the student should understand what is virtualization and usefulness of that. Okay, with this I conclude. Thank you.
Okay. Yeah, these are all the team members that we had. It's all in English, so I'll not repeat. Okay. So we thought for embedded system course, we certainly need a few programming concepts. So basics of computation, programming plus some bit of computational analysis certainly required. CMO is required because we'll be doing more of buses, 32-bit, 16-bit, and all we'll be dealing with. Digital logic, which they do as a part of third or fourth semester, and since most of the things they'll be using in real-time embedded C and so on, so certainly a good C language grasp is very much required. As for the contents are concerned, we're going to by the definition, characterization is the specification, what kind of embedded systems, what kind of specs that you derive, so that embedded system when it's designed should meet all the requirements. So also we can stress on a few